Hi everyone, this is NLP Corgi. Today's deep dive is about the paper from Naver Cloud HyperCLOVA X 32B Think. This video walks through HyperCLOVA X 32B Think, a 32 billion parameter vision language model from Naver Cloud. The model is designed first and foremost to reason in Korean, understand Korean culture, and act as an agent that can use tools and interact with environments. It unifies text, images, and even video into a single architecture, and the weights are released under a commercial-friendly license, making it a practical foundation for both research and real-world applications. The motivation behind Think is simple. Humans don't reason from text alone. We constantly combine language with visual context and with actions in the world. At the same time, there's a strong need for models that really understand Korean language and culture, not just translated English data, while still benefiting from the huge English knowledge base. Finally, as AI systems are deployed into real products, they need agentic abilities, using tools, calling APIs, and solving tasks over multiple steps. Think is built to sit at the intersection of these needs. At its core, Think is a large decoder-only transformer with 72 layers and a hidden size of just over 5,000. Both text tokens and visual patches are projected into the same continuous embedding space and processed together with standard self-attention. Rotary positional embeddings give it strong long context handling, and grouped query attention keeps key value caches efficient at inference time. On the vision side, the encoder is fully trainable, which is crucial for learning Korean-specific visual patterns like local landmarks, signage, and dense Korean OCR. This diagram shows how Think processes multimodal input. Text is tokenized into discrete tokens and mapped to embeddings. Images or sampled video frames are passed through a vision transformer encoder, then linearly projected into the same embedding dimension as text. These visual embeddings are interleaved with text embeddings and fed into a single decoder-only transformer. There are no complex cross-attention towers or separate decoders, just one unified stack that jointly reasons over text and vision. Tokenization is a big deal for Korean because many English-centric tokenizers split Korean text into too many pieces. Think uses a two-step process, a pre-tokenizer that respects different scripts and a subword tokenizer whose vocabulary has been carefully adapted. They prune merge rules that are unhelpful for Korean and low-utility merges from other languages. Then substitute in morpheme-aware Korean merges learned from large internal corpora. The result is a tokenizer that packs more Korean characters into each token, improving efficiency and downstream performance while keeping English code and math performance essentially intact. For vision, Think reuses a vision transformer similar to Qwen 2.5 VL, with a 3D convolutional patch embedding that can handle both images and video frames. Local window attention keeps computation manageable at higher resolutions. The team aggressively controls visual token counts. Images are capped at about 3,000 tokens, and videos at around 11,000, which is far leaner than many contemporary models. Crucially, the vision encoder is not frozen. It's fully fine-tuned so the model can internalize Korean-specific visual cues, from street signs to exam diagrams, while still staying efficient enough for large-scale deployment. The data pipeline behind Think is built for scale and cleanliness. It uses Datatrove and Nemo Curator to collect, normalize, score, filter, and shard documents. First, simple heuristics remove obviously broken or noisy content. Then, learned quality scorers kick in. For English, they reuse fast text and transformer-based regressors. For Korean, they train a dedicated quality model on a mix of curated corpora and clearly low-quality examples. This Korean scorer significantly improves both accuracy and recall on bad documents, which is key because the goal is to aggressively remove low-quality text. On top of that, they use LLMs to rewrite PII-bearing spans into safe, fluent alternatives, cutting residual PII from nearly 90% down to a fraction of a percent. Think is trained with a 4-stage curriculum that gradually ramps up difficulty and context length. Stage 1 builds a broad multilingual foundation, mostly Korean and English, with sequences up to 4,000 tokens and 6 trillion tokens in total. Stage 2 doubles the context to 8,000 tokens and injects more long-form documents, code, and chain-of-thought data, including instruction-style examples. Stage 3 pushes the context out to 32,000 tokens, tightens filtering, and leans heavily into math and code reasoning. Finally, Stage 4 is a high-quality annealing phase, dominated by carefully curated reasoning, math, code, and instruction data, tuned to maximize complex task performance. If we look at the data mix across stages, we see a clear shift. Early on, general text dominates, at nearly 80%. By the final stage, general data is down to about 17%, while code and math each rise to roughly a quarter of the mix. Instruction-style data, which starts at essentially 0, climbs to about a third of the final stage. Importantly, reasoning-oriented synthetic data, especially for math and code, is introduced during pre-training itself, not just in post-training. This early exposure has been shown to boost downstream reasoning performance. After pre-training, Think goes through two major post-training phases. First is supervised fine-tuning. On the text side, TSFT uses a mix of plain instructions, multi-step reasoning traces, and full agent trajectories that include tool calls, feedback, and verified solutions. On the multimodal side, MSFT proceeds in stages. Align visual features to text space, broaden visual knowledge, add task-oriented multimodal instructions, and finally push advanced reasoning and video understanding. Throughout, they use unified chat templates that distinguish non-reasoning, reasoning, agent, and multimodal modes, which helps control how the model structures its outputs. On top of supervised fine-tuning, Think is refined with several flavors of reinforcement learning. Multimodal RL with verifiable rewards trains the model on tasks where answers can be automatically checked, like math or code, with additional rewards for good formatting and language consistency. Agent RL uses group relative policy optimization to train both general agents and software engineering-style agents, with different context budgets and reward weightings tuned to each environment. Finally, multimodal RL from human feedback uses a reward model trained on ranked responses and optimizes the policy with PPO. Here, they only train on final answers, not the internal thinking traces, and they explicitly reward adherence to the chat template and to the expected language for each prompt. To make the results comparable and reproducible, the team uses a unified evaluation framework called Omni Evaluator. It separates the inference engine from the evaluation logic, so you can swap between local models, APIs, or in-house serving without changing how metrics are computed. It also bundles modality-specific toolkits for text, vision, and audio into one system. All evaluations are run with fixed, version-pinned configurations, including how answers are parsed and scored, which is especially important for reasoning models, where small formatting differences can change measured accuracy. On Korean text-to-text benchmarks, Think performs very well. It's evaluated on KMMLU for expert-level STEM and professional knowledge, on Click and Hare 1.0 for cultural and common-sense knowledge, and on Cobalt for fine-grained linguistic and grammatical competence. Across these, Think consistently outperforms comparable open-source vision language models like Qwen 3 VL and Intern VL. It even competes closely with EXA1 4.0, a text-only model, and surpasses it on most Korean benchmarks except Cobalt. On the Flores Plus translation benchmark, Think delivers the best English to Korean scores and near-best Korean to English, showing strong bilingual capabilities. For English-only tasks, Think is solid but not leading. On MMLU, it's competitive with other vision language models of similar size, but trails the text-only EXA1. On common sense benchmarks like HelloSwag and PIQA, it underperforms some baselines. This reflects an intentional trade-off. The training recipe is tuned to prioritize Korean understanding and reasoning, even if that means giving up a bit of English performance. That said, the gaps are moderate, and the model remains usable for many English applications. On Korean vision-to-text tasks, Think really shines. It's tested on KONET, which is built from Korean national educational exams, including KGED and KCSAT, and on KMM Bench and KDTC Bench, which cover general visual understanding and document or chart reasoning. Think achieves the best scores on KONET and very competitive results on the other two, often ranking first or second with small margins. This indicates that the model can handle complex exam diagrams, charts, and documents in Korean and reason over them at a high level. To stress test real-world academic reasoning, the team runs Think on the 2026 KCSAT mathematics exam, the high-stakes Korean college entrance test. They use a consensus of 64 strategy, aggregating answers from many independent runs, and feed problems either as images or text, depending on the question. The model scores exceed the estimated first-grade cutoff in all elective tracks, probability and statistics, calculus, and geometry, placing it in roughly the top 4% of human test takers. Its geometry performance is particularly notable since those questions demand precise visual spatial reasoning over diagrams. For English visual tasks, Think shows a mixed but encouraging picture. It achieves the best performance on Text VQA, which focuses on reading text in natural scenes, and is strong on Doc VQA for document understanding. On broader benchmarks like Seed IMG and Lava W, it lags some specialized models. For video, using up to 120 sampled frames, Think scores 63.4 on Video MME without subtitles, beating GPT-4V and Naver's previous HCX video model, though still behind the very latest video-optimized systems. On internal Naver KV content, it performs even better, suggesting that its video understanding is particularly robust in Korean, real-world media. To measure agent ability, Think is evaluated on the Tao 2 suite and on Terminal Bench. Tao 2 simulates multi-turn customer interactions in airline, retail, and telecom domains, where the agent must plan, track state, and complete goals. Think consistently beats EXA1 and Qwen 3 VL of similar size across all three domains. On Terminal Bench, which tests command line tool use and recovery from execution errors, Think again leads on both the standard and the hard subsets. These results show that the model can not only reason, but also translate that reasoning into effective multi-step actions with tools. The team also compares Think to much larger frontier models on Tao 2, including GPT 5.1 and Qwen 3 235B A22B. As you'd expect, GPT 5.1 still leads overall, but Think often outperforms the 235 billion parameter Qwen 3 model, despite being an order of magnitude smaller. This highlights a favorable efficiency-performance trade-off, with careful data curation, curriculum design, and RO. A 32 billion parameter model can deliver agent performance that competes with or beats much larger systems in realistic interactive settings. Stepping back, Think's main strengths are clear. It has deep, native-like understanding of Korean language, culture, and STEM content, going well beyond simple translation. Its multimodal reasoning is competitive, particularly on Korean educational and document-centric tasks. As an agent, it handles tools and long-horizon interactions better than many similarly sized models, and even challenges some much larger ones. All of this is wrapped in an architecture that's mindful of efficiency, especially in how it handles visual tokens, making it practical to deploy at scale. Think also has clear limitations. Its performance on English-centric text and vision benchmarks trails some state-of-the-art models, reflecting a deliberate choice to prioritize Korean. The training strategy is largely sequential. First text, then vision, which leads to some degradation on pure text benchmarks as multimodal training progresses, a form of catastrophic forgetting, seen in other models as well. And while its video understanding is solid, it doesn't yet match the very best video-optimized LLMs. Overall, this is a Korean-first model, not a global-first one. One of the key lessons from Think is that strictly sequentially adding modalities, text first, then vision, makes it hard to preserve top-tier text reasoning as you scale multimodal capabilities. In response, the team's next model, HyperCLOVA X 8B Omni, moves to a joint training strategy where text, vision, and audio are learned together from early stages, which helps mitigate catastrophic forgetting. Even so, Think stands as a strong open-weight baseline for Korean-centric vision-language reasoning and agentic behavior, and a valuable resource for both academic and industrial work. To wrap up, HyperCLOVA X 32B Think is a Korean-first multimodal agentic large language model. Its performance comes from a combination of a Korean-aware tokenizer, a carefully filtered and augmented data pipeline, a staged pre-training curriculum, and a rich RL stack. It delivers state-of-the-art or near state-of-the-art Korean reasoning across text, vision, and agent benchmarks, while remaining efficient enough for real services. Because the weights are openly released under a commercial-friendly license, Think provides a powerful foundation for anyone looking to build Korean-centric AI systems or to study multimodal reasoning and agents in depth.